Unit number 2, batteries for electric vehicles. The content in this unit is types of the batteries, different parameters, capacity, discharge rate, state of charge, state of discharge, depth of discharge, technical characteristics, battery pack design, and other properties of batteries. How do the batteries work? So, we all know how batteries are used in almost all the appliances so we use in our daily lives and vehicles. Chemical energy is converted to electricity with the chemical energy stored in a battery, which consists of a negative electrode cell with a surplus of electrons which are negatively charged subatomic particles. When an electric cable connects to the negative electrode cell, electrons flow from negative to the positive. Since the vehicle's engine is powered by it, the two businesses have devised a way to utilize the energy created by these flowing electrons to power a motor. It must provide enough current to the motor over a period of the time. Thus, this battery have an expiration date. Unfortunately, the battery has an expiration date of a few years. The battery dies when there is no electric flow between the electrodes. When the number of electrons on the positive and negative side is the same, because there is no current flow at this time, the battery expires and must be replaced. Electric vehicles batteries are one of the most important components of the electric vehicles and they are most expensive. By replacing internal combustion engines, they can drastically reduce pollution all over the world as transportation currently represents 27% of the world greenhouse gas emissions. Electric vehicle batteries are composed of cells and there are many types of cells. In this video, I will break them down in a characteristics and categories and go over the most important types. We will also discuss the possible future cell types and how they can change the automotive industry. The three cell formats used in electrical car batteries, the most common cell chemistries used in electrical vehicles, electrical vehicle cells versus power cells. What is the difference? Supercapacitors and ultracapacitors to boost power. Future electric vehicle battery cell types. There are the three basic types of the battery cells used in electric vehicles. First one, cylindrical cell. Second, prismatic cell and pouch cells. There are also coin cells which are used to in research and development for testing purposes but never actually used in electric vehicles. The number of cells in an electric vehicle varies widely based on the cell format. On average, electric vehicles with cylindrical cells have been 5,000 and 9,000 cells. This is in stark contrast with the pouch cells, which only have a few hundred cells and an even lower number of the prismatic cells. So coming to the what is the cylindrical cells? A cylindrical cells are the least expensive format to manufacture because they are already self-contained in a casing that offers a good mechanical resistance. The technology is not only the cost efficient but it is also mature, making it to format easy to manufacture. Because of their shape, cylindrical cells have limitations in terms of power. For this reason, electric vehicles with smaller batteries such as hybrid vehicles use pouch or prismatic cells to deliver more power during accelerations. Cylindrical cells need to be manufactured in a smaller format other than other types of the cells to make sure they dissipate heat well, helping prolong the battery life. That's why Most common cylindrical cells formats are 80,650 and 21,700. Larger formats such as 4,680 are uh, available because their new internal design allows more efficient heat transfer to the thermal adhesive used in the structural batteries. Coming to the prismatic cells. The prismatic cells can be 20 to 100 times larger than cylindrical cells. They can typically deliver more power and store more energy for the same volume because less material is used for casing. The casing's shape and thickness also allow better heat management than cylindrical cells. Prismatic cells are popular among Chinese manufacturers because their preferred cells chemistry, the lithium ion phosphate battery, currently mostly exists in the prismatic format. Laterally, prismatic cells have been gaining in popularity elsewhere in the world, while cylindrical cells used to be the most popular format, and these cells might take over a larger shape of market in the upcoming years. Coming to the third type, pouch cells. The pouch cells are made to deliver more power than other cell types. They are also very efficient when it comes they are also very efficient when it comes space use. Their soft plastic casing, however, means they have the lowest mechanical resistance of all cell types. For this reason, an additional structure needs to be added during the pouch cell assembly to protect them from mechanical damage. Now, coming to the electric vehicle battery basics. Here, what we need to know about the cells that power an electric vehicle. While the motor may be source that actually peoples an electric vehicle, the battery pack is its virtual heat and soul. If you are now in the market of a new user, you will want to pay attention to the battery spaces and be aware of the other aspects that will ultimately affect its performance. Electric vehicles use a lithium ion batteries of the various design similar to those used in the cell phones and laptop computers, only on a much larger scale. Lithium ion batteries have a high energy density and are less likely than the other types of the batteries to lose their charge when not being used. An electric vehicle's battery capacity is expressed in terms of the kilowatt hours, which is abbreviated as a kilowatt hours kWh. More is better here. Choosing an electric vehicle with a higher kWh rating is like buying a car that comes with a larger gas tank, in that you will be able to drive for more miles before needing a filling up. But be aware that because the way of electrical vehicles work, we will never actually have access to the fully battery capacity. That's why, because the car management system prevents the battery from either becoming 100% fully charged or 100% discharged to preserve its efficiency and extend its usable life. Battery capacities of the current electric vehicles range from a mere 117.6 kWh in the smart EQ for two range of the just 58 miles up to 100 kWh in the Tesla Model S and Model X that can run over for a period of miles of 300 miles before needing a charge. Battery capacities and other aspects of the current all currents of the electrical vehicles can be found on our uh, videos here. Coming to the battery capacity, perhaps the most critical factor to consider when shopping for an electric vehicle is the battery estimated range on a fully charged. As rated by the Environmental Protection Agency, you can find data on battery range and energy consumption for all current and past models of the electrical fuel economy. As we conveniently powered cars, electric vehicles are tested both their operating range and energy consumption under controlled conditions in a laboratory. They are driven on a dynamometer, which is like a treadmill for cars, using multiple standard driving schedules. So, simulate city and highway motoring. An electric vehicle begins testing with a battery fully charged and is operated until it becomes fully depleted. However, an electric vehicle's actually range on charge can vary according to a number of factors. Lead footed acceleration and drive at higher speeds will tend to use more kWh than would more manually around the town motoring. The battery will also drain at a quicker rate when operating with a full load of passengers and cargo. All else being equal, a heavier vehicle will consume more energy to reach and maintain a given speed than will a lighter one. Importantly, an electrical vehicle state of charge will more quickly in extremely cold or hot weather. Frigid temperatures in particularly can sustainably hamper both the battery's performance and its ability to accept the change. What's more, while gasoline engine generate large amounts of the heat that can be harvested to warm a car's interior, an electric vehicle's climate control system relies solely on battery power. A recently study found that when the mercury dips at 20 degree Fahrenheit and the vehicle heater is in use, an average electrical vehicle's range drops by the 41%. That means a model that's rated to run for 150 miles in a combined city or highway driving would only be able to muster around 88 miles on a charge. The same represented the outside temperature hit the 95 degree Fahrenheit and air conditioning in use. An electrical vehicle's range will drop by an average of 17%. Coming to the charging an electric vehicle's battery, most electric vehicles charging is done at home, either through a conventional 120 volt circuit known as a level 1 charging or a dedicated 240 volts line called level 2 charging. Depending on the vehicle's battery capacity, it can take anywhere from the 8 hours to more than 16 hours to achieve a full charge using level 1 charging. Though it will cost a few $100 to have an electrician install 240 volts service in your garage, it will pay off in the terms of the charging time as a short as 4 hours. If your energy provider offers a discount for electricity tapped during a off peak hours, you can save money by scheduling a charge in the middle of the night. There is an even quicker alternative called level 3 charging, though it's limited to a small but growing system of public charging stations, also referred as DC fast charging. It can bring an electric vehicle's battery up to 80% of its capacity in an little as 30 minutes depending on the vehicle. Beware, however, that an electric vehicle battery will take longer to replenish in a cold weather than it will at warm temperatures, no matter which level of the charging is being used. Coming to the third one, battery warranties. Unfortunately, all electric vehicles batteries will be degrade somewhat over time and lose a bit of their ability to maintain a full charge. This is not a dire a warning as it sounds. However, according to the organization Plug-in, the average Tesla Model S losses only 2.3 miles of a range for every 10,000 miles driven. Tesla itself reports that in controlled testing, its batteries retained 80% of their range after running for a simulated 500,000 miles. Shorter range electric vehicles, on the other hand, may suffer added deterioration as draining most or all of a battery charge on a regular basis will tend to cut into its capacity more quickly over time. On the pulse side, federal regulations requires than the electrical vehicles battery pack, which can cost thousands of the rupees to replace, be converted under the warranty for at least 8 years or 100,000 miles, whichever comes first. For its part, 100 extends to its lifetime coverage on some electric vehicles. So finally, so in this particular battery vehicles, if you are buying or selling a used electrical vehicle, keep in mind that any remaining part of the batteries originally warranty will be transferred to a subsequent owner or not. Types of electric batteries used in electric vehicles. Here the types are five types of the electrical vehicle batteries: lithium ion battery, nickel metal hybrid battery, lead acid battery, solid state battery, nickel cadmium battery. The lithium ion battery subdivided into five types: lithium iron phosphate, lithium titanate, and lithium nickel manganese cobalt, lithium manganese oxide, lithium nickel cobalt aluminum oxide. These are the types of the batteries used in electrical vehicles. Types of lithium ion batteries. There are different types of lithium ion batteries, and the main difference between them lies in their cathode materials. Different kind of lithium ion batteries offer different features with the trade-offs between specific power, specific energy, safety, lifespan, cost, and performance. The lithium ion battery types that will be comparing are lithium cobalt oxide, lithium manganese oxide, lithium nickel manganese cobalt oxide, lithium iron phosphate, lithium nickel cobalt aluminum oxide, and lithium titanate. Before choosing the type of the battery, there are some important points to be considered which offers the battery performance. Coming to the first point, a specific energy. This defines the battery capacity in weight, Wh by kg. The capacity relates to the runtime. Products requiring long runtimes at moderate load rate are operated and optimized for a high specific energy. Second one, specific power. Its ability to deliver high current and indicates loading capability. Batteries for power tools are made for high specific power and come with a reduced specific energy. Coming to the nominal voltage, it is the system voltage at which the device is desired to operate. The rated voltage is higher than the nominal voltage to ensure the safe operation of the device. Coming to the cycle, the change and discharge make a cycle. The current rate, this is used to determine the fast charging capability of a battery. Thermal runaway, it is a condition where an increase in temperature changes the conditions which increase the temperature further, often leading to a disaster. Next one is the performance. This measures how well the battery works over a wide range of temperature. Most batteries are sensitive to heat and cold and require climate control. Heat reduces the life and cold lower the performance temporarily. Lifespan, this reflects the life cycle life and longevity, and it is related factors such as the temperature, depth of discharge and load. Hot climates accelerate capacity loss. Cobalt belted lithium ion also used have a graphite anode that limits the life cycle of this battery. And what is the safety? Now, this point related to a factor such as the thermal stability of the materials used in the batteries. The material should have the ability to sustain high temperatures before becoming unstable. Instability can lead to the thermal runaway in which flaming gases are vented, fully charging the battery and keeping it beyond the designated age reduces the safety. Coming to the cost, the demand for electric vehicles has generally been lower than anticipated, and this is mainly due to the cost of the lithium ion batteries. Hence, the cost is a huge factor when selecting the type of lithium ion battery. Now this slide shows the following different differences between the each type of the lithium ion batteries based on their characteristics. And lithium cobalt oxide, the specific power is low, specific energy high, safety low, lifespan costs low, and performance is the medium. And what is the application here is cell phone, camera, and laptops. What is the voltage range here? 3.60 volts normal nominal. Typical operating range is 3 to 4.2 volt per cell. And another one is the lithium manganese oxide. The specific power is the medium and specific energy is the medium, and cost is low here. The performance also low. What are the applications here? Power tools, medical, electric vehicles here. The voltage range here is the range is 3 to 4 volts per cell. And coming to the another one, nickel, lithium, nickel, manganese, cobalt oxide, and here is the range is 3 to 4.2 volt per cell here or higher values, and applications is power tools, medical, and electric vehicles. Coming to the another one is lithium iron phosphate, and here the range for this one is the 2.5 to 3.65 volt per cell. The applications are power tools, medical, and electrical vehicles. Coming to the another one is the lithium nickel cobalt aluminum oxide. The range for this is also same, 3 to 4.2 volts per cell here. Applications are grid storage and electric vehicles. So last one is the lithium titanate, and this is also operating range is the 1.8 to 2.85 volts per cell. The applications are grid storage and electric vehicles. And